to my video on calculating pH and calculating pOH. The first thing that we are going to go over is the estimating pH. This is not taught in the book. It's not covered in the book. It's not, I don't think it's in any of the videos. I don't remember it being in any of the videos that I listed. So here we go. I'm going to teach you how to estimate the pH of either a hydrogen ion concentration or a hydroxide ion concentration. Now, something I want you to remember as you are going through, we have our hydrogen ions, and in a lot of the videos, they talk about the hydronium ion. And the hydronium is the H3O plus, okay? Hydronium and the hydrogen ion concentration, it's the same thing, okay? So just know those are the same thing. Now, right here, I have given us an example of a hydrogen ion concentration of 3.2 times 10 to the negative fourth. This is how you can estimate the pH, because estimating the pH is going to help you know if what you calculate, the pH that you calculate, is probably correct, okay? Because what we are doing is we are estimating the pH range. So your pH, your estimation is going to be a range, not an exact number, okay? So we can estimate the pH. First of all, look at the exponent, okay? So we have our exponent right here, -4. The things I am learning that I can do with this program. Let me get back to my little scribble thing here. So my exponent is -4. So I take that -4 and I take the absolute value of that number. Now, I don't know if any of you have gone over absolute values in math, but the absolute value of -4 is 4. Okay, so basically all we are doing is we are taking our exponent, this negative exponent, and making it a positive number. That's all we're doing. We just make it a positive number. And then we can determine the range by taking whatever the exponent value is that we just calculated, which is 4, subtracting 1, so 4 minus 1. 4 minus 1 equals 3. Okay, so the first number in my range is 3, and then it is 3 to 4. So your exponent, so the pH, sorry, your estimated pH is going to be between 3 and 4. Okay, you can do the same thing with pOH. If you are given a hydroxide, so there's my hydroxide. If I'm given a hydroxide concentration value, I can look at the exponent on the hydroxide and determine the estimate, the estimated range of your pOH the exact same way. Okay, here is now calculating your pH. Sorry, erasing everything here. There we go. So when I calculate the actual pH, yes, somebody asked, you use logs? Okay, I don't know if any of you have learned what a log is yet in math, and that's okay. You don't need to absolutely understand logs. You just need to know, at this point, how to calculate it using your calculator. So we will take, in order to calculate your pH, I'm going to take my hydroxide ion concentration and I'm going to plug it into this equation up here. So when I write my equation, it's going to be pH equals the negative log of, now I'm going to use the same 3.2, sorry, my point didn't show up, times 10 to the negative fourth. Now I would plug that into my calculator. If you have your calculator, right here I have this, the TI-84, okay? All you need to do is use the log button. Okay, on this one, it just has log right there. You can kind of see it on the button. So you would just take your calculator and plug in, okay, now some calculators you have to do log. You have to hit the log button first. And then you plug in your concentration, 3.2, and you can do the EE because this is the TIs, and then -4, and hit enter. Now, notice I didn't say anything about the negative log. If you can see on my calculator, yes, it's backwards, I'm sorry. It says that it is a negative 3.94. Okay, so you can think about it. I've got this, that is not, so negative. So the answer to my log of 3.2 times 10 to the negative fourth is a negative 3.94. Notice I've got a negative out here and I'm multiplying it by a negative number. That makes my answer a positive number. So the pH, the actual pH of a hydrogen ion concentration of 3.2 times 10 to the negative fourth is 3.49. Sorry, I said 94. And so this would be the answer. Okay, so like it says, solve this on your calculator. Some calculators don't let you do the log or negative log. If you cannot put the negative in front, probably the easiest thing to remember is if you get a negative answer because of you have a negative answer and you're multiplying it by a negative, then it becomes a positive number. Okay, pHs, the pH values that we are going to be calculating will not be a negative number. Okay, to answer a quick question, yes, there are negative pHs, kind of approximate negative pHs, but not on this normal pH scale. Those are exceptions. Okay, now what about pOH? Log of pOH. Well, we calculate it the same way using the log of your hydroxide ion concentration. So remember, some of you asked about that. That is the equilibrium constant of water. K, capital K, represents equilibrium constant. The little W here at the bottom, that represents that it is the equilibrium constant of water. The equilibrium constant of water, when water is at equilibrium, your hydrogen ion concentration and your hydroxide ion concentration are equal. And that also means that your concentration is going to equal 1 times 10 to the negative 14th. Notice that 14, that's the top end of the pH scale, the top number of the pH scale. So if we know our hydrogen ion concentration, we can plug in the hydrogen ion concentration, and I am going to use the same 3.2 times 10 to the negative 4th. So I have Kw equals, I have my 3.2 times 10 to the negative 4th times my hydroxide ion concentration. Sorry guys, this is really hard to write this with a mouse. Equals 1.0 times 10 to the negative 14. Okay, so there is my equation. Now I can solve for my hydroxide ion concentration by dividing. So let's do this. Hydroxide ion concentration equals, whoops, sorry, 1.0 times 10 to the negative 14th divided by 3.2 times 10 to the negative 4th. Okay, so now I can do that calculation. 1.0 times 10 to the negative 14th divided by 3.2 times 10 to the negative 4th. And this equals 3.125 times 10 to the negative 11th. Okay, that is the hydroxide ion concentration. Okay, now I can take this value and I can plug the OH value into the pOH. Okay, so that is, I can do that. So I can take this value and I can solve for pOH equals the negative, the negative log of 3.125 times 10 to the negative 11th. So if I calculate the log of 3.125 times 10 to the negative 11th, I get equals a, well, it says, so negative 10.5051498. Okay, Whoops, that's a bad 8. Like I say, it's difficult drawing with a mouse. So we get this value. Notice, remember that the pH, pH, I think I'm trying to go faster than the computer is going, equal 3.49. 9. There we go. Notice that this number, and when I multiply my two negatives, I end up with the positive. That number and this number equals 14, or would end up equaling 14. So the other way that you can, besides doing it this process, you can solve for the pH value, and then you can subtract the pH value from 14, and that will give you the pOH. Okay? All right. After all that, let's clear this. Let's talk about calculating concentration differences. There's got to be a better way to erase this. So calculating concentration differences from the pH. So remember, the pH scale is a logarithmic scale. That means that every step on the pH scale is a factor of 10. So someone asked on the questions, what's a logarithmic scale? A logarithmic scale is also what we would refer to as an exponential scale. If you remember from long ago, we did half-life. A half-life graph looks like that. That is an exponential decrease, or we also call it, it is a logarithmic graph because it decreases or increases as on a logarithmic scale or by exponents. Okay, so here is how I would do this. I have my eggs that have a pH of 7.8. I have vinegar that has a pH of 2.8. What is the hydrogen ion concentration difference? So the way we are going to do this, we find the difference in our pHs. So I've got 7.8 minus 2.8, which equals 5. So that is my difference. Now, I can make that difference, the number that is my difference, an exponent of 10. So I now have 10 to the 5th power. Okay? This is exponential, which means that each step you are multiplying it together, not adding it together. Okay? Because there's a difference. This is the same thing as 10 times 10 times 10 times 10 times 10, right? That's what an exponent is. If I were adding these up, I would have written 10 times 5, which is 10 plus 10 plus 10 plus 10, whoops, plus 10. So that's the difference. This is not, no, we're not doing it this way. Okay. it is the exponent. So I make it 10 to the 5th power. When I multiply 10 to the 5th power, the easy way to do it, and this is the easy way I remember, I draw my 1 and I add as many zeros after as my exponent. 3, 4, 5. So that means that vinegar is 100,000 times, there's 100,000 times more hydrogen ions in vinegar than there are in eggs. Okay. So remember that if you're looking at pH, it's the lower one that has more hydrogen ions. Whoops, there's 100,000. Okay, maybe I need to slow down. Okay, sorry, it's taking it a second. So there's 100,000 times more H plus in eggs than there are, in vinegar than there is in eggs. Okay, I hope that this helps. If you have any other questions, please let me know. Email me and I will try to answer individual questions. Thank you. Have a great day.